In this video, we are going to be discussing the background of early atomic theory. So, the first thing that we're going to discuss is what is the definition of an atom? As you can see in the slide, an atom is the smallest particle of an element that retains the characteristics of that element. So, in the image that we have here, we can see that there's aluminum foil. Aluminum foil is a representation of the element aluminum. And as you can see here, we have some shiny gray spheres representing each of the atoms of aluminum that have to come together in order to make the foil. Understand that in this section, we are going to just talk about the experiments that led to the understanding of how elements are formed by atoms. We are going to start early atomic theory by talking about Greek philosophers, because understanding the idea of what nature and matter is made out of, it was something that was intriguing even in early days. So during those times, there was the Greek philosopher Democritus, and he proposed an atomic theory along with his mentor, which states that all atoms are small, hard, indivisible, and indestructible particles made of a single material that forms into shapes or in different shapes and sizes. What was he proposing during that time? If we look at the examples that we have in the bottom, and again, I understand water is not an element, but if we look at it conceptually, at that point, what he was trying to propose was that if we compare different substances, they each are made out of these tiny particles that make them unique. So just to give an example, and again, I know water is not an element, but if we look at it in terms of the substance, he was trying to define that the substances that are all around us are going to have different shapes and they're going to be made out of a single material. Later, we're going to discuss how people started thinking of atoms specifically and what are they composed of. But understand that during these days, he was just trying to rationalize all the concepts. In addition, Democritus was the one that developed the word atom. So these small, hard, indivisible, indestructible particles, he actually named them átomos, and that's what the word atom comes from. Understand that during his time, even though Democritus was revolutionary, people really did not agree with his idea. Because during that time, Aristotle was one of the philosophers that was most well known, and he did not support the atomic theory idea that Democritus was proposing. Aristotle was more of the philosopher that believed that all these substances in nature actually came to rise or was developed by the combination of the four forces of nature that include earth, wind, fire, and wind. So, did I say the four? Earth, wind, fire, water. Anyways, those are the four. So understand that because he had that proposal, people really did not agree with the Democritus idea that everything around us, the substances around us, were made by these particles, which he called átomos. Now, it took 2,000 years for Democritus' idea to be proven scientifically. And it was by the work of John Dalton. John Dalton showed experimentally that atoms were made out of tiny particles of matter. He illustrated that. Now, he also said that the atoms of an element are going to be similar to each other and different from those of other elements. what does that mean at the end of the day? In his theory, because at this point, he just illustrated that matter was made out of small atoms. He was saying maybe these atoms have some components that are similar. So if we think about it in terms of the illustration that we have in the bottom of the slide, they're going to have the same shape, meaning that they're circles. But they're different from each other because they're a different element. So maybe they have different sizes. And again, this is a theory back in the day. He also determined that atoms of two or more different elements are going to combine to form compounds. So it is also illustrated in the figure that we have in the bottom. So if you take oxygen and hydrogen, and specifically if you combine two hydrogens and one oxygen, that can give rise to a molecule, for example, water. And lastly, in his theory, he said that atoms are arranged to form new combinations in a chemical reaction. So he was already proposing that these atoms can undergo changes and give rise to brand new compounds. Now, understand that in early atomic theory, the experiments that came after John Dalton's theory and discovery were trying in essence to support his idea. It's just that along the way, brand new discoveries were also made. So the next main experiment that we need to talk about is J.J. Thompson's cathode ray experiment. Because once John Dalton proposed that matter was made out of atoms, what J.J. Thompson was trying to prove is actually support the idea that matter was made out of atoms, but he wanted to see, are these small particles actually affected by other things like weight or magnetism or charges for that matter? So Thompson, in his experiment, that you can see it in the illustration that we have in the top right corner, I think this is a cathode ray. In a cathode ray, basically there are some discs at the end, specifically right here, that if you charge them, then that is going to give rise to this ray that I'm circling in black. So that's the cathode ray specifically, okay? So he actually illustrated that these cathode rays contain negatively charged particles. So with his cathode ray experiment, because in essence what he did is that he put, as you can see, a magnet, and he saw that the cathode ray was attracted, okay, to the positive side of the magnet, meaning that this ray needed to be negatively charged. With his experiment, then he said, these atoms actually have what are called subatomic particles. So the atoms have smaller pieces to them, and J.J. Thompson actually was the one that discovered electrons, which at that point, those were subatomic particles because they're smaller than the atom. Now, with the discovery that these cathode rays had negative charge, meaning that atoms actually have charged particles that are negative in them, then he proposed a theory for the atom. Now he said, let me develop a model of how an atom looks like. So again, these are just theories. So here he developed a model in which he said, like, okay, I can see that atoms may be circles, and then these circles are going to have the negative electrons in there. But during that time, they also understood that if you have something negative, it needs to be balanced with something positive. So he proposed that these negative electrons are going to be surrounded by a positive cloud or a positive area that is going to contain them. He called his model the plum pudding model because it's named after a dish that actually looks like fruitcake, okay? And in this model for the atom, he said that these electrons, okay, were surrounded by this positive area. Understand that protons is something that was discovered later. So the protons are another subatomic particle. But J.J. Thompson does not discover them. And understand that in his idea, we have the electrons, we have a positive cloud or a positive area that is surrounding these electrons. And that was his contribution. Again, he did the plum pudding model and he discovered that electrons were one of the subatomic particles that were present in these atoms. So then Rutherford, to support J.J. Thompson's idea of having these subatomic particles that he called electrons being surrounded by a positive charge, he did the gold foil experiment. Okay, and in the gold foil experiment, understand that here in the middle we have like a graphical representation of how the experiment actually looks like. So he had a beam of particles that will be shooted to a gold foil, and again, gold is an atom or is an element. And then he's going to have a detector. And the idea is that Rutherford wanted to show that, yes, these electrons are going to be surrounded by a positive cloud. So if I shoot this gold foil with a beam of particles and this cloud of positive charge is surrounding the electrons themselves, then what I should see is that overall they should be undeflected particles, okay? Because overall we're going to have an area of positive. And he did see that there's some undeflected particles. The important thing out of the gold foil experiment is that he also saw deflected particles. Because the deflected particles gave the idea that maybe this positive charge wasn't all over the atom, maybe it was more localized, okay? So with the gold foil experiment, what Rutherford contributed to early atomic theory is the discovery of a small, dense, positively charged nucleus, okay, inside the atom that deflects specifically the positive particles that came close to it. So with this discovery, then we now know, and other people were involved in this work. Then after that, they found the other subatomic particles, protons and neutrons. But again, Rutherford's was just to define that we have a nucleus in the atom where we have that positive charge. So it's not all over, it's just in the middle of the atom. Now, by the end of atomic theory, okay, this is the structure of the atom that we visualize. Okay, so this slide summarizes the idea of where are we at by the end of atomic theory. Okay, we know that an atom consists of a nucleus that contains two subatomic particles, protons and neutrons. The electrons that J.J. Thompson discovered are in a large empty space that is around the nucleus. And this is the only thing that early atomic theory does not addresses. Is there a particular location for the electrons? Are the electrons just free flowing within the atom of an element? Or are they more localized? Do their energy is quantized? All of that we're going to answer when we retake this topic later when we talk about modern atomic theory. So for now, understand that in this image that we have in the middle of the slide, we have lithium metal. Lithium is made out of lithium atoms. And those lithium atoms are going to have electrons. And in the nucleus of the atom, we are going to have protons and neutrons. Specifically there. Now, understand that these subatomic particles that I just mentioned are summarized in table 4.5 of your textbook. The three subatomic particles, even though there's more known to date that you guys are responsible for knowing, are protons, neutrons, and electrons. Understand that the second column gives you the symbols, so you are not confused with the different terminology that we have. Here we have the charge for each of the particles. We have the mass for each of the particles and the location inside the atom. All that information you should know for the upcoming exam.